thank you very much for having me today. I look forward to educating folks a little bit on online DGA monitoring. If you're not, well, at least trends in online DGA monitoring. For those that aren't familiar with H2 scan, we make hydrogen sensors that are included in a lot of the various online monitors globally, and so we see a lot of different things around the globe, and get a lot of questions for what's going on with online DGA monitoring, and so I thought it would be appropriate to put together a little presentation and let everybody know what we're seeing as the trends around the globe. So let's see if I can. Okay, here we go. So most everyone knows all about the oil sample data. When you take an oil sample, I thought it would be appropriate. There are good things about oil samples and some challenges. And so just wanted to provide a quick review of the proper process to take an oil sample. And when you're using oil sample data to provide information about the health of your transformers, it's very important that you take a good sample, because if you have a poor sample, you're going to get poor data and may provide not the best results. And so you need to remove the sample from the transformer. Of course, there's a picture there about someone taking the sample. Many tests can be performed once you take that sample, not only the dissolved gas analysis, but there's also oil quality for acid interfacial tension, dielectric voltage breakdown. The labs look at the color, particle count, moisture content, and there's I think about 80 other tests they can perform. But these are the pretty much normal tests that people take when they send an oil sample to the lab. Typically, people are sampling on their larger transformers every 1 to 4 years. We found that in talking to various utilities that when you're looking, there's more of a trend to start monitoring distribution transformers. And as you, so we've found that as things are happening in the grid, and there's more and more of a interest in monitoring the distribution assets, we found that outside of substations, the people aren't monitoring their transformers at all, aren't taking online oil samples or any of that. So when we talk about taking oil samples, we're typically talking about distribution and transmission substation transformers. And again, most people take oil samples once a year, but depending on the practice and the ability to access the transformers and so forth, sometimes they may wait for a 3 to 4 year period. And of course, transformers with problems are tested more frequently. And so the DGA, the dissolved gas analysis on a transformer, is often compared to taking a blood test on a human. It really gives you the best idea of the health of the transformer. And so we'll go a little bit more into that. So challenges with manual fluid samples. For those that aren't on an IEEE or C-grade committee, we typically call them oil samples, but as we're getting into various alternative fluids besides mineral oil, the ester fluids and so forth, those are actually called fluids, so our terminology is changing. And so the proper, I believe the best term to use today is fluid sample. So it's important that you there are strict sampling processes that must be followed to get a good oil sample. Dumping some oil into a can and screwing a lid on, or into a jar and sending it to a lab, isn't going to provide the best results. And so it's best to use a glass syringe. Make sure that there's no bubbles in the valve that is being used to take the oil sample. You want to typically discharge 1 to 3 liters of oil before the sample is taken to ensure that you're getting a representative sample of the oil that's in the main tank. The temperature should be recorded if there's a top oil temperature gauge, or sometimes the folks taking oil samples actually can measure the oil sample directly, the temperature, and that would be the best indication. But the gases move in and out of oil based on temperature, and so it's very important to understand exactly what the temperature of the transformer was at the time the oil sample was taken. And so again, this is one of those things that when the data comes back to the lab, if these types of things aren't recorded, it can provide it's the best to have these things there. Sample, of course, must be packaged properly for shipment. Labs get samples all the time with broken sample containers. Ideally, your sample should be analyzed within 7 to 14 days. Gases like hydrogen, very tiny molecules, they can leak out of the sample, and so it's best if the labs can take analyze the sample within 7 to 14 days of the sample actually being taken from the transformer. And then, of course, once it gets to the lab has to make sure they handle all the samples properly, and they get thousands of samples a year, and so it's easy to start trying to take shortcuts. And same thing when people are taking the oil samples from the transformer. So it's important that you're following the right processes and provide, you want to be able to provide the best results possible. And of course, proper documentation must be included. So for instance, if you don't fill out what transformer the sample was from, it's going to be hard for the lab to put that in the database with that transformer if they don't have all the information that they need to properly identify that sample. Also, moisture. There's a lot of discussion and training on moisture in transformers. Moisture, you want to keep the moisture content as low as possible. And if you don't have the proper processes, taking samples on rainy days usually isn't a good idea, because it, of course, can affect the moisture that's read in the lab once it gets to the lab. So also, a very important thing that I think a lot of people don't realize is if your transformer has a nitrogen system or is a sealed transformer and has a pressure gauge, you should always check the pressure gauge to make sure that the transformer is not in vacuum or negative pressure, because you don't want to open a valve and pull a bubble into the transformer that could potentially fail the transformer, or again, pull atmospheric gas into the transformer. And so I was at a power plant in Texas one time, and a customer said, in the winter, we open the valves on these transformers and the oil doesn't come out. We don't understand why. I looked up at the pressure gauge and I said, you need to add some nitrogen pressure to that transformer, and you should not be opening those valves when the transformers are in negative pressure. So these are real things that happen, and proper training, of course, is very important. And as Randy indicated, the electricity forum provides lots of various training. I'm not sure if you do oil sample training, but if you don't, it'd probably be a good one to add to the list.
Yes, the oil sampling is part of our transformer testing and maintenance course. It's quite involved in that course.
Okay, great. So now we talk about the benefits of online transformer monitoring. So why might you want to monitor your transformer online? The very first thing is when you're taking manual oil samples, there's manual intervention in taking the sample, There's manual processes to transport the sample from the substation to the lab. And once it gets to the lab, there's manual intervention in removing the sample from the container and actually testing the sample. And so there's lots of various things that potential for things to go wrong and provide an test result that's not as good as possible. And so the nice thing about online DGA monitors is they're on the transformer. They, as long as they're installed and operating properly, they're providing real-time information, and there's no manual intervention. And so the risk of manual intervention issues is lower. You still have issues. It's not uncommon for people to go out and take a manual sample. And once you take that sample, the normal process is you close the valve. And so if there's an online monitor on that valve, now that monitor is not getting fresh oil from the transformer, and of course isn't providing the best information possible. So those kind of precautions need to be taken with online monitors. I guarantee every online monitor manufacturer has stories of customers complaining that the data doesn't look right, and they go out and the valve is closed. So the valves have to be open for the monitors to work properly. So as the DGA monitor products have been evolving over time, there's a trend in the industry to add additional things into the DGA monitors. So you're putting more and more functionality into one device, which generally is a benefit for the industry. It lowers costs and allows you to put monitoring on more devices. Also provides the benefit of the additional monitoring. So one of the big things recently is people are adding bushing monitors to the DGA. Of course, normal things that you get with DGA monitors are things like oil temperature. A lot of DGA monitors have inputs for load current, pressure, and ambient temperature. The communications provide continuous transformer health information. So a lot of the monitors provide serial communications. There is a trend in the industry to go to higher bandwidth and easier ways to connect, like Ethernet, wireless, but analog is still around, 4 to 20 milliamp and so forth. That stuff is still around. Protocols like IEC 61850 require Ethernet, and so getting data from devices that don't have an Ethernet port, you have to run that data into serial converters that convert that to Ethernet, a gateway of some sort. And then, of course, depending on the information that your monitor is providing, you have alarms that indicate a change in the transformer health. And so the big thing that I've seen over the years is a lot of companies will install lots of monitors, and a lot of those monitors, a lot of times, aren't actually connected to anything. And so you've got a monitor sitting out there on an island. It may or may not be working, may have never been commissioned, never. It's a shame that people invest all this money in monitoring and then they don't realize the benefits. And so it's very important that you have a plan, and we'll get into the things you need to ensure happen to make sure that you have a good experience with your online monitoring. So as with any technology, there are some challenges, and these are things you want to make sure that are done correctly to ensure that you get the most out of your monitoring system. So first of all, your monitor must be installed properly. There's a lot of times when monitors are specified on a new transformer and the transformer OEM isn't trained properly or doesn't read the manual and installs things, valves backwards or or mounts things on transformers. A lot of monitors cannot be shipped on the transformer. They need to be removed from the transformer for shipment and then reinstalled in the field. And so a lot of these things need to be, there's a lot of details that need to be paid attention to when installing the monitors. Again, I talked earlier about the valves getting closed after manual oil samples. You want to make sure, of course, that your folks are trained when they see an online monitor. Make sure that valve remains open after the oil sample was taken. Fluid connections may not be installed properly. Again, you got to have the right valves, follow the right procedures for that particular monitor. Communications can be a challenge. In my experience, when you have a customer that's trying out a monitor for the first time, the monitor is installed within a day or two. Getting the communications actually brought back and somebody using that information and can take anywhere from 6 months to 2 years. And so it's very important that you have a plan up front for how you're going to communicate to that device and make sure that you're realizing the benefits of having that monitor on the transformer. I worked with a customer one time that had it was an industrial site that had about 12 or 15 multi-gas units installed, and they had a 345 kV transformer fail. And of course, management said, how do we know that transformer wasn't going to fail? Well, nobody was maintaining the monitors. And so out of 12 or 15 monitors, only 2 or 3 of them had been working. And of course, the one on that transformer that failed had not been maintained and hadn't been working for a number of years before the transformer failed. And so it's important that if you've got monitors that require maintenance, that you have a plan to be able to address that maintenance and keep those monitors running. If it's important enough the transformer is important enough to have that monitor on it, it's important enough to make sure you plan for, the needs of keeping those monitors running. As installations increase, managing the data can be difficult. So if you have a handful of monitors on your system, bringing the data back usually isn't a big deal. If you're a large utility and you're going to start installing hundreds of monitors, managing that data, managing all those monitors, making sure that all the data is coming back, making sure the data is actually being used, that becomes more and more of an issue. And so larger utilities with bigger plans are developing asset health centers where they make sure that they have dedicated staffs that are responsible for ensuring that the sensors are working, the data is being brought back, and being utilized in a proper fashion to ensure that you're really getting the benefits from that monitoring. Many monitor manufacturers require that only qualified service personnel can commission or repair units. So this, again, is very important when you're going into a major monitoring plan. You want to make sure that if maintenance is required, that you may want to consider maintenance plans and have the manufacturer come out and perform maintenance on a regular basis or do a monitor checkup. Extended warranties are sometimes specified. Some monitors actually need to be sent back to the manufacturer for repairs. And so it's important for customers to do their homework ahead of time to make sure that they understand what's necessary to ensure that their monitors stay working over a long period of time. When you have a transformer that's going to last 30 to 60 years, and your monitor is going to need maintenance every 4 to 6 years, it's important that you incorporate that into your plans. Also, repair part availability can be an issue. This has become a big issue over the last few years with COVID and the inability to get parts for monitors. A lot of I've heard from customers that there are manufacturers out there that you can buy the new monitor because that's a large expense, but getting parts has been a challenge. And so the manufacturers are, of course, putting the, they want to get the most revenue possible. So You want to make sure you're working with folks that are going to be able to support you the best. And of course, if you have repairs, again, some manufacturers will provide training, or if there's service required, it's something that's easy to do and customers can do it themselves. Or if you do need to have the manufacturer come in and do the repairs, you need to have a plan and ensure that somebody's responsible for scheduling the manufacturer to come out and commission and or repair the monitoring. And again, due to challenges with uptime on monitors, many customers are now requiring a 10-year warranty for their DGA monitors. And so, and that way they're able to ensure that, with public utilities, there's always an issue of capital dollars versus maintenance dollars, and it's much easier to spend capital dollars than it is maintenance dollars. And so the one thing that we hear fairly often is our transformer monitors require so much maintenance. We're maintaining our monitors more than our transformers. And so again, if you're purchasing monitors that are going to require maintenance, you want to make sure you plan for that. And if that's a problem for you, then you want to make sure that you're buying reliable monitors that aren't going to require that much maintenance and have a very long life, preferably with no maintenance. So what do you need to do to be successful? And so, first of all, select the right monitor for your transformer. Of course, critical transformers justify more comprehensive solutions. So if you've got typically generator step-up transformers are the number one thing I think of when I think of a critical transformer, because if you lose that transformer, you lose that generation, and no matter what the transformer costs, the cost of your lost generation is going to be significantly more than what that transformer costs. So you want to make sure that your generator step-up transformers are monitored properly, and if there's any issues, those are addressed right away. Less critical transformers, of course, can have more basic monitoring. Of course, plan for maintenance activities if necessary. Obtain the proper training for your monitors. I've sold monitors for about 15 years, and one of the primary things I've always ensured is making sure customers understand how the monitor works, how to communicate to it, what the data means, what data they need to get from it. It's important that you push your vendors to get the right training for your people. Not only the one or two guys responsible for the monitoring, but the folks out in the regions and so forth that are going to be responsible for keeping those monitors running. They need to understand what the monitor is doing and how it does it. So determine people who are responsible for commissioning, maintenance, communications, data historian, data analytics, alarm limits, and actions. Having one or two people say, "Oh, we need to put, $100,000 monitoring system on our transformers, but we're going to put it on, but we're not going to be responsible." And then the maintenance guys say, "Well, we don't have time, so I've seen $100,000 monitoring systems out on transformers that were never commissioned because nobody wanted to take responsibility for them." So, of course, you don't want to let that happen. And of course, you want to, once you identify what are your critical transformers, what are your not so critical transformers, and then, different levels of monitoring, you want to determine what are your solutions for your new transformers, your existing transformers with issues. So, of course, a transformer with issues, you're probably going to want to put more monitoring on than a transformer with no issues. And then even existing healthy transformers, no transformer is going to last forever. So having things like a hydrogen monitor that lasts 10 to 15 years with no maintenance, those are things you might want to consider to deploy across your fleet, because again, monitoring the external things like temperature and current and so forth don't really provide the the health of the transformer. I've seen a lot of transformers that are overloaded. I've seen a lot of wet transformers and so forth that are 50, 60 years old and no gassing issues. And so they just keep on humming and doing their job. I've seen brand new transformers that are at 30 to 50% load that are gassing a lot. And so looking at the external things is good, and you should do those things. But again, looking at the gases and the oil really gives you a much better idea of how healthy the transformer is, just like a blood test. On the outside, I may look very healthy, but on the inside, I could have something that I won't be living much longer. So hopefully that's not the case. But just like a blood test and a human tells you that information, the online or the DGA information in a transformer gives you that information about your transformer. And so this is just provides some possible recommendations. This is kind of the trends you see for critical transformers. Of course, most everybody on 100 MVA and up, new transformers, they put some kind of multi-gas monitor on. Depending on the voltage, if bushing monitors are appropriate, bushing monitoring is very popular today. Partial discharge is becoming more and more popular. A lot of people are putting fiber winding temperature sensors in. So instead of just using the winding temperature gauge, by installing fiber temperature sensors, you're able to actually monitor the actual temperature of the winding. And so that can provide a great indication of is your transformer designed properly? Is it at 50% load and already overheating, or are you at 100% load and the winding's still very cool? And so you have more capacity in that transformer. Vibration is becoming more and more popular. There's different people coming out with various different vibration type of systems. I'm not too familiar with those yet. Haven't actually worked with one of those personally. Load tap changer monitoring. If your transformer has a load tap changer, again, there's monitors that monitor load tap changers, but typically if a load tap changer, especially vacuum tap changers, have an issue, they should not be producing hydrogen. If they are producing hydrogen, putting hydrogen monitors on those is popular. And of course, load, temperature, and pressure. As you get down to less critical transformers, you typically put less monitoring on, as we show there. And then on healthy and non-critical transformers, a lot of people put single gas DGA monitors, and depending on the features of the monitor, you can also monitor easy things like load, temperature, and pressure. And so we are seeing trends in the industry where people are looking at adding monitoring more than just distribution substation transformers. Most people still aren't even monitoring those, but a lot of people have been monitoring those with like hydrogen and moisture monitors for a long time. And so as we get into the things like distributed generation, wind and solar and electrical vehicle charging, distribution transformers are getting more and more overloaded. And so the industry trends that we're seeing, again, most people install multi-gas monitors on transformers over 100 MVA. Most transformer fleets have working multi-gas monitors on only 5 to 50% of their large power transformers. A lot of people have been installing multi-gas monitors for 10, 15, 20 years. But if you ask them how many are working, they'll say, oh, maybe 5 to 10%, because they could justify it on the new transformer, but they didn't have the money to keep them running over the long term. And so it's important that, if you're not able to keep those multi-gas monitors running in the long term, you may want to consider a low-cost, reliable monitor that doesn't require any maintenance. And so that will identify if the transformer has problems, And then you can look at getting that multi-gas monitor working again, or adding a new multi-gas monitor to it once it becomes a sick transformer. Generation plants typically install multi-gas monitors on their GSUs. Few utilities currently install DGA monitoring on distribution substation transformers. Again, some people are doing that, but many are currently studying the benefits of that. Again, as distribution systems are being loaded in ways that they weren't designed to be loaded. For instance, electrical vehicle charging, the distribution substations or the transformers feeding those chargers are seeing loads and load changes very quickly that they really weren't designed to take. So a lot of people are looking at monitoring those and how can they monitor those, since it's not in a substation and you don't have the communications there. So how do you do that? Most utilities do not monitor or take manual oil samples on distribution transformers outside of substations. So basically run to failure. And so most of the time transformers fail in not a newsworthy fashion, but sometimes they do fail in a newsworthy fashion and fail catastrophically. And so when that happens, of course, no utility likes to make the news with those kind of headlines. Hydrogen monitoring is becoming more common on vault transformers under sidewalks in large cities. So people are looking at installing monitoring on those vault transformers. I've talked with some people that say they've had vault monitor or transformers installed for 15, 20 years and never had a failure. But those transformers aren't going to last forever. Then you got people like Con Ed in New York that has like 28,000 vault transformers installed. So of course, monitoring all those becomes a monumental task. And so how do you do that? How do you develop a plan to do that? Interesting thing, the top picture there, China is adding hydrogen and pressure monitoring to 765 and 1000 kV bushings. So most bushings do not have a tap where you can actually monitor the gas and the oil, but these particular bushings do have a tap. So if, again, outside of China, I'm not too sure how many of those bushings are around the world that actually have that tap, but they have had some catastrophic failures. And so they've got hundreds of sensors installed now, hydrogen and pressure sensors installed on high voltage, ultra high voltage bushings. The other thing, again, since we work a lot with hydrogen sensors, a lot of people are now working on DGA analysis techniques to include hydrogen-only analytics. So John Brett's going to be coming up here shortly. I'm not sure if he's included anything in his presentation, but I know the folks at Delta X Research have been doing it. Other folks have been looking at hydrogen-only analytics. Again, we work with people around the globe, so some of the things we can talk about because it's been announced publicly, other things we can't. So a lot of people are looking at that to look at hydrogen. Typically in your manual oil samples isn't the most reliable gas because it can leak out of the transformer, it can leak out of the sample before it's analyzed by the lab. And so sometimes it's there, sometimes it's not. It's normally produced when the other gases are produced. So having the online monitor and looking to see when that's when the hydrogen is generated is becoming more and more popular, especially because hydrogen monitors today are much more reliable than they were 30, 40 years ago when they were first introduced. In nitrogen blanket transformers, some are monitoring the gas concentrations dissolved in the gas space above the oil. And so if you think about when gases are produced in the oil, it moves up the gas space. And so you're going to see that gas very quickly in the gas space versus in the oil. It takes time for that gas to dissolve in the oil and reach the monitor. And I know I'm running out of time, Randy, so I'll kind of move quickly here. Due to reduced availability of natural gas in Europe and customers switching to electric heat, and then the addition of EVs in Europe, the electricity grid is becoming more and more stressed, and the distribution utilities in Europe are actually requiring the addition of monitoring at distribution, and we're actually talking to folks that are looking at adding thousands of DGA sensors to transformers in Europe. And so that's exciting, and getting the data back using various IoT methods, communication methods over the grid is very important. At places like California, I was at a presentation recently where they talked about they're adding 1,000 EVs per day in California right now. So of course that is good from a revenue standpoint for the utilities, but being able to deal with that additional stress on the grid is definitely a challenge. San Diego Gas and Electric estimates a price tag of $2.7 trillion in upgrades necessary to become carbon neutral by 2045. So that's one utility is talking about trillions of dollars of investment over the next 20 years or so. So it's the upgrades that are necessary are just astronomical, and the need for monitoring is going to be more and more important. Of course, we talked about IoT. Getting the data back is very important, and using that data to identify issues and hopefully make your transformers last longer. Transformers at solar plants are failing within 2 or 3 years because during the day they're at 100% load, and at night they're at 0% load. It's hot during the day and it's cold at night, and so that's causing a lot of issues with the transformers at solar sites. And of course, transformer lead times right now, 2 to 3 years. You can't get replacement transformers as easy, so you need to do everything possible to ensure that your existing fleet is going to last as long as possible. Typically, I've seen that when you identify a problem early, you're able to repair that transformer at least 50% of the time rather than replace it. But at least if you replace it on a proactive basis, you're not dealing with an outage and a potential catastrophic failure. So there's a lot of benefits to having the online monitoring. And so with that, Randy, we'll see if there's any questions.
Great. Thank you very much, Leon, for the excellent presentation. We have some questions. One, is there a protocol or standard for oil sampling to ensure uniformity in results?
So there's lots of standards for, and you could probably do some training on that, right, Randy?
We do.
The number one thing I've seen is, and like Seagray, they'll take a failed transformer and they'll send the samples to global labs and see what the results come back. The number one thing I've seen is people, it's very important to send your samples to the same lab every time because the techniques are the same. It's rather shocking to see the results and the differences in the results when you take the same samples from the same transformer, send it to 10 different labs, and you get a wide variety of results. And so the number one thing I've seen is just make sure you're using the same lab over and over again. If you're not getting good results from that lab, there's other alternatives. So that's the number one thing I've seen.
Okay, next question. In a sealed transformer with a pressure release valve, is it recommended that you release the pressure vacuum prior to sampling, or do you not need to equalize the pressure because you allow gases to escape into the air or be drawn in?
So this is probably covered in your training, but if there's positive pressure, there's usually no need to equalize it. Because the transformer is holding positive pressure, and when you take a sample, that positive pressure is going to help push that oil out. If there's negative pressure, you absolutely want to, it's better to add dry nitrogen into the system rather than just equalize it with atmospheric air. But a lot of distribution transformers have the what they call a pop-off valve or little keychain thing there that you pull and equalize the pressure. And so if there's negative pressure, you definitely want to equalize that pressure before you take the sample.
Okay. How long can a sample sit before testing and analysis?
So it can set indefinitely, but ideally, again, it's best to have that sample analyzed within 7 to 14 days of the sample being taken from the transformer. The faster you take the sample, the better the results are going to be.
Okay. Does online DGA replace manual DGA, assuming the system installed is correct and properly maintained?
So as I started out, the reason I provided the background on manual DGA is because typically you don't recommend when you add a monitor that you never take another manual DGA. There are a lot of tests, a lot of things that manual DGAs and labs can perform that an online monitor does not consider. And so things like fluid quality and furans and dielectric strength, all those things can't be done by an online monitor. And so it's important that you keep doing your manual samples, even if you have an online monitor. But what we do see is that a lot of people, especially if they have the multi-gas monitors, they extend the time that they're taking samples. For instance, if they're before they installed the monitor, they took samples every year. If the monitor is showing, good, no gassing and your moisture is looking good, then you don't. You might be able to extend your sampling to every 2 or 3 or 4 years. It really depends on your circumstances, your transformers, what your experience is. Some people have a failure rate about 0.5% a year. Some are up around 2 or 2.5%. And so, again, your experience can, with not only the transformers but also the monitors, can allow you to extend the time between samples.
Okay. Can single gas monitors be used on all size transformers, even to supplement multi-gas monitors on large transformers?
Absolutely. So it's interesting that the hydrogen monitors are getting smaller and smaller today, and to the point where they can pretty much monitor any fluid-filled transformer. So whether it's a 1,000 MVA, large transmission transformer, or even an oil-filled PT or CT, there's monitoring solutions available for those today. So the big thing that I try to talk to people that have, say, hundreds of multi-gas monitors installed, but only 10% of them working, it's important that at least the hydrogen is monitored so that you're able to tell if the transformer is gassing and you can do something about that versus having a multi-gas monitor on there that's not working is not providing any value.
Okay, does measurement error occur in online DGA due to sensor malfunction? And if so, what's the best course of action?
And so again, depending on your monitor and the technology they use, it's important that you work closely with your vendor to understand if the monitor is out of calibration. Is there an alarm for that? Do they tell you that? For instance, some monitors will tell you if the overall monitor isn't working, but say if the hydrogen value is no good anymore because they're using a sensor that only lasts 3 to 5 years, and they may not alarm that. So the only way you can tell that is by comparing your online value to your manual DGA, and then you start asking questions. Why don't these match up as close as they should? And so it's another good reason to take periodic DGAs, is to ensure that your monitor is working properly. Some monitors, they verify every day that every gas is working properly and the monitor's in calibration. Others don't do that. So it's important that you understand how your monitor works and get the most out of your monitoring system.
How is sulfur monitored?
To my understanding, there is no online monitor that monitors sulfur. that has to be analyzed by a lab. So you have to send it to a lab and ask for that test to be performed.
Can the same DGA test be performed on silicone liquid?
Yes. So silicone fluid is not, it was popular for a while, not that many of those around, but yes, labs perform DGAs on silicone. Some online monitors work in silicone fluid, some don't. And so again, you need to understand the monitoring that you're installing, and is it the right monitoring for the application.
Does DGA test a significant effect on room temperature, example, where the test is taking place? I guess, does DGA have an effect on room temperature, or does room temperature have an effect on DGA results?
Okay, so I think that's probably,
Yeah.
so if you're taking, I'm going to guess at the meaning of this question, when you take a sample, the transformer may be at 80 degrees C. And so again, that should be documented when you take the sample. Of course, when the sample cools down to room temperature, when it's analyzed, you know, that's, as long as it's a good sample, the gases should stay in that sample. As long as the sample is analyzed properly within a good short period of time, you should get good results. But the big thing is you need to make sure that you're documenting the temperature of the transformer when the sample is taken.
Okay, great. Okay, thank you very much, Leon.